This episode of Photonics Hot List is sponsored by Metallark Optics, where they take on what others won't. Challenge accepted.
Hi, I'm Justine Murphy, Senior Editor of Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Climate change is happening, and it's happening fast. The retreat of sea ice, one of the key indicators of climate change, is particularly concerning as it's already impacting the commercial shipping industry and native communities, not to mention the wildlife that calls those regions home. But scientists everywhere are working to help, including at the University of New Mexico. A team there has tapped into a telecommunications fiber optic cable off the shore of Aloktok Point in northern Alaska. At one end, they connected a distributed acoustic sensing interrogator, which sends light pulses throughout. Those light pulses bounce back at multiple points along the cable, showing how much deformation has occurred in the sea ice every few meters. The technique recorded ambient seismic noise in fine spatiotemporal detail. Along a 23-mile section of the cable, the team observed abrupt changes up to about 6 miles that occurred in less than 24 hours. The researchers are using machine learning to process the data they've obtained, which can be used to track the retreat and formation of sea ice in greater detail. With COVID-19 variants continuing to emerge, scientists, including a group led by researchers at Nagoya City University in Japan, remain determined to stay one step ahead in the fight against these threats. In a series of experiments involving two COVID-19 Omicron variants, BA2 and BA5, the team has found that UV light at wavelengths that are typically hazardous for mammals can effectively inactivate and eliminate disease-causing microorganisms without harming any human cells. In their work, they isolated the two Omicron variants and subjected them to various doses, as high as 18 millijoules per square centimeter, of UV irradiation across the 200 to 260 nanometer wavelength range. They discovered the human-safe 220 nanometer range, which falls into what's known as the Far-UVC, inactivates and kills the microorganisms present in those two variants. And UV light as high as 260 nanometers, which is typically hazardous for humans, can do the same thing and just as safely. The researchers say their findings show Far-UVC light could potentially be used to prevent airborne transmission of not only COVID-19 variants, but other viruses as well. Imagine how many lives could be helped, saved even, if cancer screening and testing were simpler. That could someday be possible thanks to a sensor that mimics natural body functions. Researchers at MIT have developed a prototype sensor modeled after our body's natural sensory systems. It detects and identifies the same molecules that naturally occurring cell receptors can. The technology, which specifically detects an immune molecule called CXCL12 with extremely high sensitivity and specificity, is inspired by the membrane that surrounds all cells, in which thousands of receptor proteins detect molecules in the environment. In their study, the researchers modified those proteins to allow them to survive outside of the membrane. The proteins were then anchored in a layer of crystallized proteins on an array of graphene transistors. Essentially a bioelectronic interface. Critical receptors in biological systems can be identified, harvested, and converted into electrical outputs. The information is analyzed by machine learning algorithms and ultimately can be relayed to a computer or smartphone. The new sensor could someday be used in healthcare settings or even at home for routine screening of cancers or metastatic tumors that are difficult to diagnose. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, and visit laserfocusworld.com for the latest and coolest news and information. Until next time.